Hey everybody, and welcome back to ModiMate's step-by-step project guide. We are taking you from the first strokes of a project right through to the final outcome of instant DWGs, renderings, and quantity estimates. In the last video, we talked about stairs and how there are multiple levels of detail that you can model stairs at. In this video, we're going to talk about cabinetry and how there are multiple levels of detail you can model cabinets at. In this project, there are some interior cabinets that we can use as a case study here. But much like stairs, the important thing to know about cabinets is that there exists a schematic cabinet tool in ModiMate, the cabinet tool found here under the Attachment Tools menu, and there's also a means of creating cabinets plane by plane for when you want more specific control over your custom millwork. We're skipping around a little bit because these two approaches involve working in the massing graph or working on the surfaces of your separators. So if you're watching these videos chronologically, you probably have mostly watched massing graph videos, and one of the ways to model cabinets is using the massing graph. That's what we will demonstrate. However, there also is a schematic cabinet tool that attaches to the surfaces of separators. We will demonstrate that as well. In fact, because it's simpler, we'll start with the simple tool, which is going to involve a little bit of skipping past topics that we've talked about. We'll cover these in future videos. But what I'm going to do is place a floor in the project and then place a surface graph on that floor. This surface graph is the location where cabinets can be drawn. Now, I have access to different snap points here, and I can draw the footprint for a cabinet, such as going out 2 feet and then across 3 feet, and then holding shift to close this surface graph. The difference between a surface graph and a massing graph is that the massing graph, as seen in the first view, is a three-dimensional set of connections between planes. The surface graph is attached to the face of a separator. This floor here is a separator object, and we are now looking at the surface attached to its top. Look at me, I'm giving away all sorts of important information from future videos, but trust me that we will go over what a separator is and what a surface graph is in further detail in future videos. You can just Google for those topics, separators and surface graphs. The important thing is that this face of this surface graph is a site where a cabinet can be extruded. I can pick from one of a bunch of cabinet out-of-the-box recipes, such as 1 drawer over 2 doors. We call each of these presets, and you can click on the face of this surface graph and extrude a cabinet up, let's say 34 inches. Then pick a front, and we see that the cabinet has automatically been deployed with its front and a toe kick. I see a slightly erroneous top drawer depth, so if I change my separation height to not be 2'5", but rather just 2 feet, we'll find ourselves with a slightly better ratio between the doors and the drawers. But again, I'm having to use tools that I haven't fully explained, such as the BIM designer for editing preset properties. But that's one way to make a cabinet. It's really fast. It's a bit fragile because when the surface graph that you've placed this cabinet on ever changes, such as it thinks of its edges as being one continuous surface graph edge from here to here, and if I use my massing graph and split the floor that it's attached to with an edge such as this one, it adds a new vertex to this floor. That new blue line has just emerged, which causes the surface graph on which the cabinet was drawn to fall off. The surface graph, whenever the number of points around its perimeter changes, it sheds and needs to be drawn anew. So cabinets can tend to fall off when you make significant changes. That being said, it is the fastest way to get some cabinets up into the space. So if you feel like using the cabinet tool, then you can use the surface graph and the cabinet as we previously demonstrated. And one more time, that is surface graph onto the face of a separator. Use the surface graph tools to subdivide the surface, for example, by 3 feet and 2 feet. And then use the cabinet tool to extrude the cabinet 3 feet, for example, and choose a front face. I can choose this face, or I can choose this face each time the cabinet finishes its box. Let's talk about the second, more granular way to create cabinets, using the 3D massing graph. If we do not have floors yet and we want more precise and durable representation of our cabinets, we can create their boxes using massing graph planes. We can do things like drawing a cabinet out 2 feet, over 3 feet, and back. As a matter of fact, this edge was arbitrary. I drew that a moment ago. I don't need it. I'll delete it. We can now draw the rest of the cabinet box vertically. Let's go up that 2'10" as previously drawn and over. We'll use the rectangle tool to complete the rest of this rectangle. I will just bring this one across, and we've successfully carved a prism in the corner of the room. We haven't drawn its toe kick yet, so what I can do there is come up 4 inches and back 4 inches, or how about 3.5 inches, 3.5 inches, and then come down and snap to here. You'll notice that when I drew this toe kick, the front of the toe kick, I used a rectangle tool and I extruded the rectangle vertically in the same plane as an existing face. It kind of looks like you're going to create 2 faces because of this, what we call Z fighting, the 2 planes that are coincident, and at every frame it randomly chooses which one to show. Modimate knows how to consolidate these planes so that when you click, it minimizes the planes and there are no redundant planes. When I click, I now have a single plane in this place. When I delete it, it goes away. There's no duplicate planes being created. That being said, I need to delete this toe kick, and I will use the join tool to join the overall room floor to this floor. Now I'll also delete this extra edge here. I now have a cabinet box that also includes a toe kick. And previously I used a cabinet object which with one simple extrusion knows how to create the whole box and decorate the front with a set of doors. Here we will use a wall assembly that we can edit and make very thin. For example, we'll talk about walls again in the future, but if I equip this assembly, if we assume that it's actually going to have a thickness more like 3/4 of an inch and made of something like plywood, I will just very sloppily make a facsimile of a plywood layer here. When I equip this assembly and I place it on the sides of the box, we end up with all the construction that we would want to be shown in our DWGs. The front assembly here should not be straight plywood. Next, we would use something like a countertop tool here in the countertop tools. We can place a countertop material on top of this box. We have a few out of the box, but lots more stone materials that we can talk about in a future video about customizing countertops. And then lastly, there is, within our door tool, a series of doors specifically for getting into cabinets. Of course, if you want to be very silly, you can place real doors on a cabinet box. We don't need to do that. We can look at the bottom of our list where we see a series of doors that are really for cabinets. We see things like double swing lower. If we place double swing upper, 3 drawers, for example, one drawer over 2 doors, placing this on the front of the box is ends up creating an outcome that is just like the cabinet box that we placed on our surface graph, except that it is based on a massing graph, so it causes some things like extra fragmentation of neighboring assemblies, and it will survive when you change the shape of neighboring assemblies like a floor. There's nothing that could make this set of planes die or be otherwise tossed out of the scene. So it is more durable, but also more clicks, and a little bit of a more complicated relationship to its neighbors. One thing I'll say, I didn't plan on covering this during this video, but as a best practice when it comes to this kind of plywood siding for the cabinetry, we'll be covering this in a future video, but don't worry that the plywood doesn't have to look so ugly. We can swap extra layers of paint onto the outside. As I'm doing this, I realize it's probably better to cover this in a future video, but rest assured that there's no visual difference between the two cabinet making approaches. You can have just as painted a cabinet via this approach as via surface graphs. If I were to go over here and make a surface graph, I'll add a floor. This is the grand finale. I'll make the 2 cabinet types side by side. Here I've made a floor that comes to meet the base of the cabinet. I now am putting a surface graph on it. I will now create a surface face that is 2 feet deep by 3 feet wide. And come back. With this patch, I will now make a cabinet that is very, very similar to my previously created cabinet. I'll snap to the underside of the countertop, somewhere around there, and I'll pick the front face. And lastly, instead of making a countertop, I'll stop there, but you can see that the two cabinet boxes are very, very similar. But one is made of the massing graph, the other is made on a surface graph extruded. So if you want to use fewer clicks but not have quite as resilient a cabinet, you can use the surface graph tool. And if you want a very resilient cabinet made out of very easy to control planes, you can use the massing graph tools. In the next video, we will cover additional types of millwork, including built-in bookshelves, built-in desks, and other types of custom carpentry. See you there!